Welcome to the Unit 4 Day 2 notes. Go ahead and pause the video and work out the solution to this system of equations. When you're done, unpause and see how you did. So I'm going to start by first subtracting 2x from both sides on this top one because I want to get this into slope-intercept form. Then divide everything by 3. So I've got y equals negative 2x over 3 plus 2. So if I go to graph that, my b value is 2. I'm going to go down 2, right 3. And I just keep doing that until I run out of room. Otherwise, I'm going to go up 2, left 3, as far as I can. Connect those dots. That's my first line. For the second line, I'll do this one in green. It also starts at plus 2, so I know that's going to be my solution, but I still need to graph this, so I need to have points on both sides of the line. So I'm going to go up 4, right 1, or it could have gone down 4, left 1 first. I need both of those. Connect those dots. My solution is 0, 2. That's the dot that's on both lines. So our objectives for today are right there. You can see that in your OneNote. And then first we're going to start off by remembering what a solution to a system of equations is. Okay, it is the ordered pair I should say not the ordered pair, I should say an ordered pair, because you can have multiple solutions if they're identical lines. So an ordered pair that makes both, I'm going to say all in parentheses, equations true. So when you substitute those values in from that ordered pair, you're going to get a true equation for both of the equations. I put all in parentheses because a system of equations could have more than 2 equations. I could have 8 equations. I draw all those lines. If they all intersect at one point, that is a solution. So how do we write the solution to a system of equations? As an ordered pair. The solution is an ordered pair, so we write it as an ordered pair. So ordered pairs always have parentheses and a comma in between them. You'll have some number x, some number y. Those numbers will be actual numbers. You're not going to write x and y for your solutions, but you will solve for x, so x equals, and then y equals, and you'll put them in alphabetical order in the ordered pair. So for this one, we're going to start by solving without a graph. You will not always have a graph, so you need to find a way to solve it without. All this is substitution. Okay, previously we've substituted in a value for a variable. We've substituted in like 6 for x or something like that. This is going to be the same idea. I know that y is equal to 2x plus 8, so I'm going to replace y in that second equation. All right. I need to make sure I go from one equation into the other, because if I replace this y that's highlighted with the highlighted stuff, I didn't really do anything. I'm not advancing my position at all. So I'm combining these two equations essentially to figure out what x is going to be first. Because I replaced y, so now I'm left with just x terms, and I solve this like I would normally solve for x. So I'm going to start by adding 3x to both sides, because I like to have positive variables. Subtract 8 from both sides, and then divide both sides by 5. So I've got x equals negative 14 over 5. It doesn't seem like a fun number, but that's okay. Now what I'm going to do with this number is I'm going to replace one of these other x's. It doesn't matter which one, it's kind of your choice, whichever one you think is easiest. I'm going to replace that x right there. So I'm going to have y equals 2 times negative 14 over 5 plus 8. When you're multiplying by a fraction, you do top times top, bottom times bottom. The number 2 is just 2 over 1. So this is negative 28 over 5 plus, I'm going to write 8 as 8 over 1 because I need to find a common denominator. So I multiply top and bottom of that by 5. By doing so, I'm actually just multiplying by 1 and not changing the value at all. So I can get that y is going to be equal to, that's going to be a positive 12 over 5. So my ordered pair is negative 14 over 5, 12 over 5. That does not seem like a nice number whatsoever. But if I plug these numbers in, Okay, if I plug that negative 14 over 5 in, I get 12 over 5 in this one. If I plug it in here, I should still get 12 over 5. All right, that would have been a negative 12 over 5 plus, and then, or plus, I said plus. It should be minus 6, so minus, and then you're going to end up negative times negative. It's going to give you that negative 3 times negative 14 is going to be a positive 42 over 5. And then negative 6 over 5 is like negative 30 over 5. So 42 over 5 minus 30 over 5 is positive 12 over 5. Long story short, you will see fractions. You need to be able to stick with fractions, because if you start rounding numbers, like if you put 14 over 5, negative 14 over 5 in your calculator, or whatever the case may be, you're going to get decimals. Some of those decimals you're going to want to round. And then when you round them, you're going to find y. And then you're not accurate. You're close, but you're not accurate. So we need to deal with fractions. Next time, on this one, we don't need to do anything to that first equation. This second equation already tells me y equals something. So if you get one equation that you have y equals something or x equals something, that is the one that you substitute into the other. So I have 3x minus 7 times, I need to have parentheses. Remember, I've always talked about anytime you replace a variable, you put it inside of parentheses, because now I need to distribute. Negative 7 times 1/7 x is going to be minus x. Negative 7 times negative 2 is plus 14. Combine our like terms. Subtract 14 from both sides. Divide both sides by 2. Got x equals negative 9 over 2. I can plug this into either equation. It does not matter. I'm going to plug it into this one first, because that one is already solved for y. So I've got y is equal to 1/7 times negative 9 over 2 minus 2. Top times top over bottom times bottom. And I'm going to write 2 as 2 over 1 so that I can multiply top and bottom by 14 to get a common denominator. So that gives me y is equal to negative 37 over 14. So again, I've got two values. My final answer needs to be written as an ordered pair. They're ugly numbers, but they are numbers still the same. You're not always going to get two sets of fractions. Sometimes you'll get two sets, sometimes you'll get one set, and sometimes you'll get none. It'll always depend on the question. So for this example, we already have x solved for, so I'm going to replace x in that second equation. So I've got 2 times 4y minus 6 plus 3y equals 10. Make sure to distribute. Okay, I know I'm going through some of these problems pretty quick, but basically this first step is the new thing. The rest is what we've been doing for the last 2 or 3 chapters. I'm going to combine my like terms to have 11y minus 12 equals 10, plus 12 to both sides. Divide by 11 to get y equals 2. Now I need to plug this thing in. I need to figure out what x is. This is the equation that's solved for x, so I'm going to plug it into that equation for y, because that is what I found. I found y. So x is equal to 8 minus 6. So x is also equal to 2. Now, this may not have been the best example for a mistake that happens on a problem like this. My ordered pair is 2, 2. If you mix the order up, I'm not going to know in this case, but this first 2 is because of x. A lot of students like to say, I've solved for this thing first, so they put it first. You solved for y first. Y is the second value because x, y is alphabetical, first and second. You're not always going to have the letters x and y. That's okay. Okay, the process is still the same. This one is solved for a, so I'm going to plug that in for a in that top equation. Make sure to have parentheses. When I distribute, 8 times 1/4 is 2 times b. 8 times negative 3 is negative 24. Combine my like terms. Add 24 to both sides. We've got negative 3b is equal to 33. So that means b is equal to negative 11, because a positive divided by negative is negative. So I'm going to plug that in to that b right there. So I've got a is equal to 1/4 times -11 minus 3. Well, that's just negative 11 over 4 minus 3 over 1, which I can multiply top and bottom of that thing by 4 to make sure that I get my common denominators of 4. So a is negative 23 over 4. That doesn't simplify. None of these fractions we've really had so far have simplified. If they could, we would simplify them. My ordered pair is always in alphabetical order. So my solution is negative 23 over 4, negative 11, not negative 11, negative 23 over 4. Now back to x and y. If you wanted, you could try to manipulate this first equation, try to get it in slope-intercept form, and then set the things equal, but that's a lot of extra work that you do not need to do. I have negative 2x minus 3 times negative 2x plus 7 equals 3. Distribute that negative 3, so I've got plus 6x minus 21. So 4x minus 21 equals 3. Add 21 to both sides. Divide both sides by 4. I've got x equals 6. Okay, plug that in here. I could plug it in that top equation, but then I have more work involved. I'm going to try to do the least amount of work I can on these problems. So y is going to equal negative 5. So 6, negative 5 is my solution. Now, I boxed this answer down here. I should not have boxed that one because that's not my answer. I can underline it as like a, hey, make sure you use this number, but my answer is the ordered pair 6, negative 5. If you box x equals 6, you're telling me that's your final answer when it should not be. All right, so now we're going to solve these systems in two ways. So basically all that means is graph it and solve it algebraically. Sometimes one will be faster than the other. So in this first example, I'm going to solve algebraically first because I think that's going to be faster. If I take that and plug it in here, I have negative x plus 6 times x minus 2 equals 3. Make sure to distribute that 6. Combine like terms. Add 12 to both sides. Divide both sides by 5 to get x equals 3. Plug that in here. Y is equal to 3 minus 2. Y is equal to 1. So I've got the ordered pair 3, 1. So that's where these two lines should intersect. I'm going to rewrite negative x plus 6y equals 3 over here because I want to be able to figure out what this is going to be in slope-intercept form before I start graphing it. So add x to both sides. Divide both sides by 6. Got to make sure I divide all the terms by 6. So if my b value is 1/2 like it is here, I don't want to try to like zoom in and like guess where a half is. That's not going to be accurate. So what I'm going to do instead, especially since my slope is going to be, oops, don't really know what just happened there. Since my slope is going to be a value that is another fraction. Sorry, my OneNote decided I wanted to freak out, I guess. I got to scroll all the way back down. Let's see how far we went. All right. So I'm rising 1 and running 6 normally. When it comes to slope, the scale doesn't really matter as long as it's consistent. So I'm going to make a note and say each square, if I could spell and write neatly, that'd be even better. Each square is, I'm going to go 1/2 by 1/2 because of this value right here. So my y-intercept I can still mark as this then. If I want to go up 1 over 6, I could go up a full 1, which would be 2 squares, and then over 6 full squares, which would be 3 squares. I said that backwards, but I can just still count boxes. I don't need to worry about the scale when I'm counting my slope. So I'm going to go up 1 over 1, 2, 3, 4, 5, 6 to right there. I can't go any further to the right. So I'm going to go down 1, left 1, 2, 3, 4, 5, 6 right there. this is the most amount of dots I can get on the graph for this one. Now, that second equation was already in slope-intercept form for us. So I'm going to graph that one in red. It was at -2 for its b value. But remember, -2 is now actually down 1, 2, 3, 4 squares because of our rescaling. I'm going to go up 1 over 1. And I can do that for each square until I get to this point right there. I should go one more past. Now if I count this over, this is 1, 2, 3, up 1, which is our ordered pair that we had right here. The tricky part is making sure we're counting by the scaling that we did. All right, so this is an example where algebraically it's a million times easier than graphing. On this next one, I'm going to do the same thing. I'm going to solve it one way and then the other. This time I'm going to solve by graphing first, just to be different. So for this first one, I'm going to again write it over here on the right side and solve for y. So subtract 3x from both sides. Now we have a fraction. So when I'm having a fraction, I'm going to multiply both sides by the number that's on the bottom. Okay, I'm ignoring that negative part for a second. So I'm now going to have -2y is equal to -9x plus 15 when I distribute. Now I divide everything by -2 to get y is equal to 9x over 2, and then minus 15 over 2. Okay, that's 7.5, minus 7.5. But the same issue we had before, we don't really want to try to guess where it's at. That makes us have a little bit more of an issue. But I could try to say, I'm going to go by 1/2. So each square is 1/2 by 1/2 again. We'll see how this works. So if I'm down 7.5, that means I actually have to go down 15 squares. Well, there's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So that's going to be an issue. So that's another example of why these graphs aren't always going to be the best way of doing it. So I'm going to have to break a rule real quick. I'm going to have to estimate. All right, so I'm going to go down 1, 2, 3, 4, 5, 6, 7.5 would be right about there. Now my slope is up 9 over 2. Okay, up 9 over 2, counting the squares. Well, now I'm between the squares. So if I go up 7.5, I know that's 0. So it'd be 8.5, 9.5 would be right there. So then from that point I go over 2. Now I can go up 9 over 2, but I'm going to be off the graph again. I would be about right there. Generally, we don't want to draw off the graph, but we don't really have much of a choice in this problem. And the second one, I'm going to start at -9, which is right here. And I'm going to go up 6, up 1, 2, 3, 4, 5, 6 over 1. Up 1, 2, 3, 4, 5, 6 over 1. So if I look at these, they're very, very close to having the same slope, but they're just a little bit different. So right here, I'm guessing that's my answer. So that would be 1, -3. But I'm not really sure because if I had to do a little bit of estimating. So instead, I'm going to solve algebraically. Plug that in for y. So I've got 3x minus 2/3 times 6x minus 9 equals 5. When I'm distributing this 2/3, basically what I'm going to do first is just multiply the 2 times the numbers in here and then put all over 3. So I'm going to have minus 12x over 3 and then plus 18 over 3 equals 5. Even though I can simplify those just so I make sure I distribute appropriately. Then I'm going to simplify, combine like terms, subtract, so I go -x equals -1, multiply or divide both sides by -1 to get x equals 1. If I plug x equals 1 into there, I've got y is equal to 6 times 1 minus 9. So I've got the ordered pair of 1, -3, which is what we found right there. So that way it was a lot less work. All right, so here's a spot for you to write your summary and any questions you may have. Hope everybody has a great day.